Hello and welcome back. In this video, we're going to find the integral of 1 over x squared plus 6x plus 13. And we're going to do this by continuing our exploration of inverse trig function integrals. And so in this problem here, you'll again notice that there is no radical whatsoever in it. So we should not be applying inverse sine or inverse secant. So this leaves us with inverse tangent. Remember the form for the inverse tangent. We're looking at the integral of 1 over 1 plus u squared du, and this integral doesn't have that form. But if you think back to past stories in algebra, we looked at these kinds of things before and completed squares. So the idea here is to take this integrand and focus on our denominator and complete the square. We need to make sure, first of all, we have a leading coefficient of 1 on the x squared. If we do, we're ready to complete the square. If we don't, and we have a constant there other than 1, we need to make sure we factor that constant out of the denominator and pull it out front of our integral. But again, we have a leading coefficient of 1, so there's no need for that. So completing the square, next thing you want to do is take that b number or middle number, and we're going to take half of it and square it. So half of 6 is 3, 3 squared is 9. So we're going to add 9 to complete the square, but also subtract 9 to keep our expression balanced. And we still have a plus 13 that is trailing behind. And again, this is all with respect to x. You will now notice that I can combine those first 3 terms and rewrite it as a perfect square, which is going to be x plus 3 squared. And then we can combine the 2 constants behind into one single number. So this is the integral of 1 over x plus 3 quantity squared plus the number 4 with respect to x. So we're getting close to our form, but again, we want a 1 plus u squared. So we have to once again do some factoring. So this time around, we're going to factor out that 4, and we're going to take it out front. So this is 1/4 the integral of 1 over x plus 3 squared over 4 plus 1 with respect to x. And again, you'll notice we multiplied in that 1/4. It would cancel the 4's in the first term and have us with a 4 in the second term in our denominator. Next up, we're now going to rewrite that x plus 3 squared over 4 as x plus 3 over 2 quantity squared plus 1 with respect to x. And we can now see what we need to take for our u. We're going to let our u be x plus 3 over 2. All right, so I'm going to let u equal x plus 3 over 2, which is the same thing as just 1/2 x plus 3 halves. Taking the derivative, that's just du equals 1/2 dx. So now making our replacement, we've got our 1/4 out front. Our integral is 1 over u squared plus 1, which is great. And then we have our dx, which is going to be 2 du. So we've got a 2 du back there as well. Just like in our previous problem, we can take that constant and simplify it with the number out front, our other coefficient. So you end up with a 1/2 integral of 1 over u squared plus 1 du. We now recognize that this is the derivative of the inverse tangent of u. So this is 1/2 inverse tangent of u plus c. And then finally, replace the u with what it was, which was x plus 3 over 2. So our final answer is 1/2 the inverse tangent of x plus 3 over 2 plus arbitrary constant c. And again, you can check your answer by taking the derivative and simplifying it down to the original integrand, which was 1 over x squared plus 6x plus 13.